Hi, I'm Lalit Vasist and you are watching Engineering Made Easy. Today we will learn how to calculate the mean or average value of random variables. Okay, so here is the formula to calculate the mean or average value of the random variable. We will also discuss a numerical example so that this concept becomes more clear to you. So for continuous random variable, there is a continuous random variable x and I want to find its mean value, okay, or the average value. So this is the formula to calculate the mean value, okay. This is the notation mx, okay, and integration from minus infinity to infinity x fx dx. Here what is this? This x f of x is probability density function. We have discussed the probability density function in the previous video lectures. You can watch the videos if you do not know what is probability density function. So by using this formula we can easily calculate mean value of the random variable x, okay. Now this mean value is also known as the expected value. The another name for mean value is expected value. That's why it is also denoted as ex, expected value of the random variable x. These both are the same notation for the random variables mean value, okay. If I have a function g of x, okay, and it transforms a random variable x into another random variable, in that case this is the formula to calculate the mean value. I will explain you this concept with the help of an example, how a function g of x transforms a random variable x into another random variable, okay. So the notation for this will be m equals to g bar of x, or expected value of g of x. This is the formula. Let me show you, because you will need an example to understand this concept, what I want to say. This is the formula, just integrated from minus infinity to infinity g of x f of x dx. This is nothing, again the probability density function, okay, and g of x is the function, another function. Let me show you how. Look at this example. Here I have a random variable z, okay. There is a random variable z. Actually I have already a random variable x, and I have another random variable z that is denoted as z is equals to cos of x. It means that this x is a random variable and the cos of x is another random variable z. So now I have a random variable z. So this random variable x has been transformed into another random variable z, and this x, this random variable x, is distributed uniformly in the interval minus pi to pi, and I want to calculate the mean value of this random variable z, this new random variable z. And this is given that this the probability density function is given, because we will need it. It is 1 upon 2 pi from minus pi to pi, and 0 for other values except minus pi to pi. I want to calculate the mean value or the average value of this random variable z, which is given as the cos of another random variable x, okay. Now how to calculate this kind of mean? We have seen the formula to calculate this kind of random variables mean, and we will assume that g of x is here cos x, okay. Z that was given as cos x, we will consider it as g of x, and we'll use the formula. Our formula was this. This was our formula, that the mean, calculate the mean, we will integrate it from minus infinity to infinity g of x f of x dx. F of x, this is a probability density function, has been given. Look here, this has been given, and also we are given the g of x. G of x is this. G of x is cos x, okay. So we know both of these things, gx, g of x, and f of x dx. Just we need to integrate it from minus infinity to infinity. Here it is written that x is also a random variable, so that the function g of x transforms random variable x into another random variable z. We have discussed it. So let's put the values of g of x and f of x in the limits. We know that this m is equals to, since the limit is from minus pi to pi, because it was defined for minus pi to pi. See the limit. This function f of x, this probability density function, is defined only in the range of minus pi to pi for values of x minus pi to pi, and For other values that are not lying in this range, its value is 0. So we will integrate it from minus pi to pi instead of minus infinity to infinity, because for that range it is 0. So only we will consider the limits from minus pi to pi, and g of x, f of x. This, the probability density function is 1 upon 2 pi from minus pi to pi limits. For other values it is 0, and g of x is we are just applying the formula cos x. G of x is cos x dx. Okay, so just integrate it, take this constant out, 1 upon 2 pi minus pi to pi cos x dx. We know the integration of cos x is sin x with respect to x. Okay, limits minus pi to pi, 1 upon 2 pi, upper limit minus lower limit, sin of pi minus sin of minus pi. Okay, simple integration. 1 upon 2 pi, sin of pi is 0. We also know that sin of minus pi is also 0, so it is 0. Another way to solve it, sin of minus x is minus of sin x, so it becomes minus of sin of minus pi becomes minus of sin pi. So minus minus becomes plus, so sin pi is again 0. So 1 upon 2 pi into 0 is 0. So its mean value for this random variable is 0. Okay, I hope you understood the concept. Although it was easy, if we can have another example where we are given the random variable x only. Okay, no another variable, another random variable. That was very simple. We can use the simple formula, this simple formula, x into this will be given to us, and x we will integrate it from minus infinity to infinity with respect to x. Okay, but it was easier, so I did not provide you the example for this simple problem. Instead, I provided you the example for this problem. Here at the place of x we used g of x. Okay, so you know how to use this. I hope you understood the concept of finding mean of random variables. Okay, and in the next video we will see the variance and moments of random variables like standard deviation, variance, and central moments, another various kinds of moments. Today we will discuss random variables and what are discrete random variables and continuous random variables. These are two types of random variables, so we will discuss these both kinds of random variables here. But before knowing what are random variables, let me tell you some terminologies that will be used here. What is sample space? Actually, the range of all possible outcomes of an experiment is known as the sample space. Okay, so whenever we perform any experiment, like suppose we are tossing 3 coins at the same time. Okay, this is the experiment. Okay, and then we may have heads or tails on any of these coin. So either we may have heads on all these 3 coins, we may have tails on all these 3 coins, or 2 heads, 1 tail, and 2 tails, 1 head. So there are a lot of possibilities. There are total 8 possibilities. So all these outcomes of this experiment of tossing 3 coins is called the sample space. All these outcomes are under this sample space. And what is random variable? Here first let me tell you the definition of these sample space and random variables. After this I will explain you what is a sample space and random variable with the help of example. So a random variable is a function. It is a function which can take on any value from the sample space. The sample space contains all the outcomes, all the possible outcomes of that experiment, as we have seen in the coin example. So this takes on some values that are part of sample space from this, okay, from this sample space, and having range of some set of real numbers, okay, is known as the random variable of the experiment. So let's make it more clear with the help of our example. What is sample space and what is random variable? So let's here take an example of our experiment of tossing 3 coins at the same time. We are simultaneously tossing 3 coins. So as already discussed, these are the 8 possibilities, because the first coin may have either head or tail, two possibilities.
and the second coin may have two possibilities, and the third coin may have two possibilities. So 2 into 2 into 2, there are total 8 combinations, 2 cube. So these are the 8 possibilities. This is the possibility is arranged, this is also taking into account the arrangements. I mean, 2 heads, these are the combinations. First coin is having head, second is having head, third is having tail, and here the order has been changed. So total 8 combinations, so these are total 8 outcomes. So this is the sample space because it contains all the possible outcomes of this experiment. Now let's suppose the number of tails is the random variable x. We will understand this x, how we can take some values from this sample space and make our random variable. So we name this random variable as x, and it will contain the number of tails in this experiment, and this x1 value is 0. It means in this case here we are only taking the number of tails in the random experiment in this experiment. So number of tails is, here it is 0. In this case we have how many tails? Only one tail. And here also we have one tail, but in this case we have two tails. So two tails, and all these 3 tails. So here we have considered or taken only the number of tails from this sample space. Therefore it is a random variable, and we have named this variable as x. So this is a discrete random variable. As I told you that there are 2 kinds of random variables, continuous random variable and discrete random variable. So this is an example of discrete random variable, as we have finite number of outcomes, and these values are denoted by x1 to x8. Okay, so now we will see types of random variables. Classification is discrete and continuous random variables. So what are discrete random variables? The example that I have given you of this 3 coins, tossing 3 coins, was an example of discrete random variable. So these are the random variables which can take on only finite number of values in a finite observation interval. As in this coin example, we had only 8 outcomes. So this can be counted. So it has finite number of values in the outcome in a finite observation interval. So we can say that discrete random variable has distinct values that can be counted. It is very clear. So this is the same example that we have already seen to explain you the concept of sample space and random variables. Now we will see the continuous random variable. So it has continuous outcomes. Okay, a random variable that takes on infinite number of values, we call it as continuous random variable, while discrete had only certain number values, certain number of outcomes that can be counted. So it has infinite number of that cannot be counted. The outcomes are infinite. So many physical systems can produce infinite number of outcomes in a finite time of observation. Okay, in such cases we use continuous random variables to define outputs of such systems. Okay, so here we will see 2 examples. Suppose we want to perform a job. Okay, somebody wants to perform a job, then he can complete this job in different time intervals. Suppose I want to fill a tank, then somebody can take 2 hours to fill that tank, and the same person can fill this tank in different time intervals. Okay, he can take different times to fill that tank. And also if we consider other persons, then the time taken by other persons to fill that tank will be different. So the point is, the job is same, but the time to complete that job can contain infinite number of times. Okay, it can have any value. So this is an example of continuous random variable. So this has been given here. So this job is continuous random variable since there are infinite number of times, that is different times to finish that job. The another example can be of of the noise voltage that is generated by electronic amplifiers. As we know, electronic amplifiers generate noise signals, noise voltages, and it has continuous amplitude. Infinite number of values of amplitude are produced by that electronic amplifier. So the sample space will contain infinite values. It will be continuous, and the random variable that we will obtain from that sample space will also contain range of continuous values. So this was all about random variables and its types: continuous random variable and discrete random variables. Hope you got the point. So keep watching my channel Engineering Made Easy, and please don't forget to subscribe it. And if you like the video, please click on the like button and share it.